from homework. Have you completed it? Okay. Roll number 18. Eldiren. On your mic. Voice is breaking. I think Eldiren. Number 18. Oh, Eldiren left the meeting. Okay, good. Very nice. Next is the Vamsi, 29. Roll number 29, Vamsi.
Yes, sir.
Please unmute your mic.
Yes, sir.
Okay. You tell me what is the
Yes, sir. I have solved it, sir, and I got a value as 6, sir.
6. Okay. So, where it is located?
Sir, your voice is breaking, sir. I can't hear you.
I'm asking what is the location of the pole? Pole. My voice is not clear.
Sir, your voice is breaking, sir.
Am I audible now?
Yes, sir.
Or still it is breaking? It's fine, right? Yeah. No, my question is, what is the pole location? If I want to place the pole on the S plane, where it will?
Yes, sir.
According to your calculation.
Yes, sir. Since given an fourth order
Yeah.
characteristic equation,
Yeah.
in taking a equals to 6, we get fourth row as all zeros, sir. So there must be an oscillation in the system. So there must be two poles lying on the imaginary axis, sir. And if
What
you
is the
observe,
location I'm asking? Can you tell from the question itself?
yes, sir. Given natural, yes, sir. Natural frequency given as 2 radians per second, sir. So poles may be at
Yes.
plus 2 j omega and minus 2 j omega.
Yes. No, plus or minus 2 j omega. Plus or minus j omega. Omega
No,
n.
sir. Yes, sir. J2, sir.
Yeah, that is correct. Otherwise, it is wrong. Okay, fine, good. Okay, you can mute your mic. Okay. So anyway, I will also solve it. Hope everyone knows it, because in this question, we according to the question, we don't need to worry about the other poles, right? Because we don't know what is the maximum order of the characteristic equation, because it is mentioned as partial root array. Only we want to find the magnitude of A. At what magnitude of A the system will oscillates, right? So how will you do it? We can form the root array s power 4, sorry, s power 3, then s square, s1, s remaining thing we can fill it, right? So this becomes 1, a 8, 3, 12, what is the value of this one? A minus 3, sorry, a minus 3, a minus 12 by 3. So it will become a minus 4, right? Again 24 by 3, 8 will come. So what about this one? This becomes a minus 4 minus 8 by a minus 4, right? This becomes 0, this becomes 8. So this is our Utai. Now let us take the first column. That is no use, right? Yeah. Because in question it is mentioned that at what frequency it will oscillate. So how will you find when the system will oscillate? If all the elements in a row 0. So only possibility is this, right? Because we have 1 0 element, 2 0 element there, and this first element value depends upon the value of A. So let us assume this all elements, raw elements are 0. So if all the elements are 0, we can write the auxiliary equation as auxiliary polynomial. How can we write? A minus 4 a square plus 8 is equal to 0, right? So if you solve this, you can find the S value at what pole it is oscillating, right? A minus 4 square is equal to minus 8. So what is the value of S? Since minus is there, it will become plus or minus J square root of 8 minus A minus 4, right? And we know system oscillate at omega n, right? So this is the omega n. Given omega n is equal to 2 radians per second, so we can write 8 square root of 8 divided by a minus 4 is equal to 2. Right. So if you solve this, you will get equal to 6. We don't need to worry about the other pole locations, right? So if you place this, it will come plus minus 2. Okay. So hope everyone understood this concept. This is the previous gate question. Solve one more problem. Not on this question. The system shown in the figure remains stable when the given system is stable. The system is shown like this. Is that the system is also shown in the form of a signal flow graph. Okay. This is 1, this gain is K, and again S in this. This is 1 Y of this. It's like this. Gain is 3. This. So, so this is the given system. So what we have to find is whether at what value you see the question is see, there is a parameter k, right? So basically at what value of k the system becomes stable. That will be one. Right? What condition the system remains stable. So this is a given system. So how to do? So in order to check the stability, you can take root, right? So in order to form the root array, you need the characteristic polynomial, right? So first step is you have to find or you have to derive the transfer function of this particular signal for graph. Okay, so it is a very simple circuit. So you can you please complete it and tell me what is the transfer function. Okay, start. So every day you can expect this kind of questions. So I hope number of students will be less because of question only students are less. I think right today 19, it's only 16 students present. Every class you can expect. I'm not interested to. I'm not worrying about the syllabus. Only thing is whatever I am teaching, you people want to learn. Huh? Okay. Otherwise, it is not. It is not one way, right? It is a two-way thing. The output is also required. Okay, please complete it first. Who is your class leader, sir? No, no, I'm not asking you class representative, class advisor. Right?
Naveen Sam sir.
Naveen sir. Sir. Okay, okay, thank you. When we are coming back to campus, March 7th, right?
Yes sir.
Okay. See, one more thing I want to tell is where attendance is continuously tracking. Okay. So in this, those who are not having, it will show the percentage also, how much time you are attending the class. Okay. So if the percentage is not good, I will not give attendance. Those who are having good percentage, that person will only handle attendance. Okay. That also keep in mind. To inform the others also, those who are not presented and those who are coming at 10 o'clock. If class started at 8:30, some people are joining at 9 o'clock. They will not get attendance. Simply they can sit and go. Because for attendance only you are coming, right? Not studying. If you want attendance, I will give you later. No problem. Those who are interested to study alone, please join. Others, I will give attendance. No problem. Please, for attendance alone, don't attend my class. If you request, I will give attendance. You will not need to join. Please, next semester I will only mostly handle the same lab for the control system. At that time I will ask questions, but don't tell, since it is online, I did not learn anything. Okay, that dialogue don't tell me. Okay, what is the answer? It's a very simple problem only. Okay, wait. Plus 3 or minus 3. Polarity? Plus. What about others? Whether he's telling correct? Jones now. Roll number 25. That is the answer he got. Jones, please unmute your mic. Jones, are you there? 25. Okay, then roll number 24. Lenstein Peter. Jolsna, if you are not interested, please leave the meeting. Just not, please leave the meeting, Jolsna. Okay, because you won't get attendance. What about Lenstein Peter? 24. Roll number 22.
Yes, sir.
Okay, at least respond. That is good. I don't know what you people are thinking. I don't know. This is not an evaluation process. Just I want to know whether you are understanding the concept or not. That's why I am calling. I am not evaluating you. Right? If you did not understand, please tell me in which point you are struggling. You are not at all telling anything. Whenever I am asking question only, you are telling, sir, I did not understand. I did not understand. That's why I did not. I'm not satisfied. Okay. Okay. So, what is your name? Suman. Sumant, right?
Yes, sir.
Okay. You are from
Suman,
which
sir.
place? You are from which place?
Andhra Pradesh, sir.
Andhra Pradesh. Okay, fine. So, what is the answer you got? Whatever maybe, tell me. It is right or wrong? It is second.
K by S plus 3 minus K, sir.
K by S plus 3 minus K.
Yes.
Okay. Okay. You please mute your mic. Whether it is correct?
Yes,
Because
sir.
I don't have the answer. Okay. So anyway, we will do it. So you know, right, how to solve the signal flow graph, right? It is very simple only. No, the given problem is very simple, right? Anyway, we will recall everything. So according to Mason's gain formula, the transfer function y of s by r of s is equal to sigma k. It's a notation we use. I found that. Okay, I did tk, right? We used textbook. They will be t or m we used in our class. Delta. This one instead of m we used a t, right? Anyway, whatever means t only, right? Okay, fine. So where k refers to forward path, right? So in the given problem, how many forward paths are there? Forward path means we have to start from the input node and we have to end at the output node. We should not come back to any of the nodes, right? So in this given problem, the number of forward path is So this is our input node R of s. This is our output node Y of s. 1 K inverse 1, right? So is there any other feedback? Sorry, feedback forward path? Not right, because all other are coming back, right? So in our case, K is equal to 1. So what is the next step? The next step is you have to, so this becomes T1 del 1 by del, your forward path gain becomes just to multiply all the gains. So it becomes K by yes. Right. Now how many loops are there in this? 2. Because loop means we have to start at one point and come back to the same point, right? So one loop is like this. Like this, you can come back to the same node, and the other node will like this. We can start from this point and we can come back to this. So we have 2 loops, and what is the loop gain? First loop gain becomes minus K by S, right? The other loop gain becomes 3 by S. Now you have to find how many 2 non-touching loops and 3 non-touching loops. Here both the loops are touching each other. So how will you find the delta? Delta becomes 1 minus sum of the loop gains, right? So it becomes K by S plus 3 by S plus sum of the non-touching loops. In this case, there is no combination of non-touching loops. So we can write like this: 1 plus K by S minus 3 by S. And what about the delta 1? What is the value of delta 1?
1, sir.
1. Okay, 1. Fine. So now the transfer function becomes y of s by r of s equal to t1 is k by s, delta 1 is 1, all divided by 1 plus k by s minus 3 by s. So this becomes k divided by s plus k minus 3. Is it correct?
Yes, sir.
Correct? Is it correct? Yes. So in order to check the stability, we can form the root array. So what is a characteristic polynomial? Characteristic polynomial is s plus k minus 3 is equal to 0. So highest order is 1. So we can form the root array s power 1 and s power 0. So if you substitute this constant, this becomes 1, this plus k minus 3. So our first row is completed, right? We no need to enter any other elements, because only thing is, in order to check the stability, we need the first column elements. So in order to be in stable, all the elements, there should not be any sign change, right? Let us assume this is plus, this is plus, k minus 3 is plus means it should be greater than 0. So the condition is when k is greater than 3, the given system is stable. This is the condition. Clear? Yeah. So one more problem we will do regarding this. So tomorrow onwards we will start the third unit. Okay. This I won't do. You only want to do and tell me. Okay. Question is the characteristic. Sorry. Given g of s is equal to 10 divided by s raised to 5 plus 2 s raised to 4 plus 3 s cube plus 6x square plus 5s plus. This is not C of x, this is a transformation. Point. This is the question. Please find and tell me. This is a fifth order polynomial. You want to find how many poles are laying in the arrangement. Otherwise, check the stability of the system. That will be better. Check the stability of the system. Have you got the answer? Yeah. Tell me. 2 points in our speed. Have you arrived? Have you arrived at this result? What is the, is there, but is there any special case like all the row becomes 0 or all elements in all row or first element alone, right? Yeah. Ah, yeah, fine. So since you are telling answer is 2, so there is 2 sign change, right? Is it like that? Okay. What about others?
Yes, sir.
Have you
Got it.
got the answer or a got it? So everyone got the answer. So we don't need to do it again. Whether I have to solve it? I need to solve it. Yeah. So okay, then we will form the root array. Is power 5, is power 4, is power 3, is power 2, 1, power 0. Now we will enter all the elements. 1, 2, 3, 6, 5, 3. So first element becomes 6 minus 6. This becomes 0. And this becomes 10 minus 3 by 2. So it's 7 by 2. Since there is no element here after, we can put it as 0. And what about this? This 0 minus 7 by 0. Yeah, so now the special case arises, right? Means first element becomes 0. So what you have to do? You have to replace that 0 with epsilon, a small positive number, epsilon, right? After that, we can continue the computation process. So it becomes 6 epsilon minus 7 by epsilon, right? The other element becomes 3 zeta minus 0 by zeta, so it becomes 0, right? What about this one? The element corresponding to s power 1. Let me write like this element, let it be A. I will write here. A becomes 6 epsilon minus 7 by zeta multiplied by 7 by 2 minus 3 zeta, sorry, epsilon divided by 6 epsilon minus 7 by epsilon. Right? Now this becomes 0 and the last element becomes 3. This is our first column. Now, in order to check the stability, we need to check is there any sign change occurred in the first column or not. So, if we take this is a positive number, this is a positive number. Let us assume this epsilon is a small positive number. So, if epsilon is a small positive number, what will happen to this? Yeah, because it can be written as 6 minus 7 by epsilon. So this is a very small positive number. So obviously the whole term will become negative. So this becomes negative. What about this polarity of A? If you solve this, it will come as positive, right? Yeah. Let us see how it can be done like this. So this can be rewritten as 6 epsilon minus 7 multiplied by 7 by 2 minus 3 epsilon square whole divided by 6 epsilon minus 7. Right? Since epsilon is a positive number, this term becomes basically positive, right? Because this becomes it's not like that, because the numerator becomes negative. If you solve this, write like this, right? 7 to 7 by 2 divided by minus 7. So this is 7. Obviously, the output will be a positive, right? So, this becomes plus, this is already plus. So according to the rule, what the rule is telling, first the entry above the zeta, the polarity is plus, and the entry below the zeta is negative. So if there is a change occur in these two entry, it means that there are some poles located on the RSP. No. Yeah. And directly you can find how many sign changes in this. Two. Yeah, because this from plus to minus, again from this minus to plus. We have two sign changes. So how can we conclude this? Number of sign changes first column of root terms is equal to 8. That means number of roots since two poles lies on the RSP of the axis S pi, the given system is unstable. Clear? So I hope everyone understood the concept clearly. So in coming units also we will use this concept. So please do work out some more problems. So today we are completed our second unit, and Friday we will start. Tomorrow we will start the third unit. Okay. So if you have any doubt, please call me and ask. Okay. Soon your first assessment will be there. So please work out more number of problems from the textbooks. And if you have any doubt, please ask me. Clear?
Yes, sir.
Yeah.